Okay, today we'll be learning about symmetry. Have you all learned symmetry in primary school? What did you know about symmetry? Okay, okay, good, very good keywords that I'm hearing from everybody. Technically, when you fold them, right, it is not that they are similar, they are exactly the same. Okay, similar means something else in mathematics. Similar means same shape, different size. But in this case, for symmetry, when you fold, you get exact same shape, same size. So when you look in a mirror, you see a reflection. It is symmetrical. Same shape, same size. So yes, that's what we learned in primary school. We also learned that there is this thing called the line of symmetry. Now the line acts like a mirror. So whatever is on one side will be reflected onto the other side. So for example, if we have the following shapes, we start off with a blue rectangle on the left. So there's this dotted line over here that is the line of symmetry. When you fold the rectangle along this line of symmetry, you'll find that you get a narrower rectangle, but both halves are exactly the same. So that is what we mean by a line of symmetry over here. Okay, now if we look at a green triangle, the same dotted line over there representing a line of symmetry, I need you to be able to visualize that you can fold and you get exact same shape on both sides. Are you able to visualize that? Can you imagine in your head? If you can, yes, you have a good idea of what symmetry is about already. And similarly for the last one. So this is a five-sided figure called a pentagon. When a shape has a line of symmetry, we say that it is symmetrical. And what about the three other shapes shown at the bottom of the page? For example, the green triangle over here, is there a line of symmetry? Is there any way that you can fold this triangle such that you get two exact same halves? Is it possible? Diagonal, is it? This way? Then which way? Like this? Like this? Cannot. You cannot. You cannot. So we say that this has no lines of symmetry. It is not symmetrical. Okay, Sherry, you can trace it out on a piece of paper and try and fold in any way. You cannot. Okay. Now let's talk about the last one first. The one in red looks like a trapezium. Likewise, you cannot draw a dotted line such that when you fold along the dotted line, you get the same shape. Cannot. There is also no lines of symmetry. Now this over here, what is this shape called? Parallelogram. Yeah, it's a parallelogram. Does it have any line of symmetry? Have or not? What do you think? Looks like have, right? It is. I suppose you all are talking about this line, is it? Anybody thinks that this is a line of symmetry? No, huh? Why not? Yes or no? Okay. Turns out if you go and draw the parallelogram, and when you fold it along this dotted line, you're not going to get the same shape. I mean, it is not going to fit nicely with each other. You are going to end up, wow, this is difficult. If I fold this side over, it will look like this. Can you see? If you fold the bottom up, you will get that shape. This is the portion that is folded up. Okay, so it doesn't fit nicely. That's why we say it's not symmetrical. And so of course, if you try the other way, you try to fold it this way, yeah, you get the same, you have the same problem. It's going to go up this way and this way. Vertical, like this. So when you fold this over, gonna have this. Okay, wait, vertical, okay. Before you vertical, you're gonna get. You see the half on the right. You fold it over, you're gonna get that shape. So it doesn't fit exactly. So what about if you try horizontally? So you fold this one up. See the long one over here will end up over here. Then you get it shape. See that? The bottom one, when you fold up, it doesn't fit nicely again. So parallelogram is the one that causes students to always think that there are lines of symmetry. And we have just talked about all four of them, which are common mistakes. They are actually all not lines of symmetry. Okay? So don't have. No lines of symmetry. No lines of symmetry. However, for a rectangle, are there any lines of symmetry? Rectangle? Have right. Vertical. There's a vertical line of symmetry. There's a horizontal line of symmetry. Got diagonal. Cannot. Imagine a rectangle. Can you fold it this way? Can? You got paper, right? Just take a paper and try fold. You fold diagonal. Are you gonna get the same? Are they gonna fit nicely? You got a book, right? You can just choose one page and just fold. Cannot. Cannot. So no diagonal lines of symmetry for a rectangle. Only vertical and horizontal. But for a square, we've got horizontal, we've got vertical, we've got diagonal also. The square is special. There are four lines of symmetry here. Okay, so in real life, right, we actually can find lines of symmetry. For example, this cupboard, this has lines of symmetry. Then what about this picture over here? Is there a line of symmetry? What is this picture about? The landscape, right? Then that's water at the bottom. So the water acts as a mirror, isn't it? So where's the line of symmetry? Okay, here, right? So actually you can draw the line of symmetry. You can also draw for this cupboard, line of symmetry vertically down. Wow, this has many lines of symmetry. Can you find them? Many. For example, this over here, everything on the left, same as everything on the right. Of course, this is if we continue drawing all the way. We've got horizontal lines of symmetry. You have diagonal. There are many lines of symmetry. All this horizontal. Leaf also. Vertical, horizontal, diagonal. Wow, this one got many. Okay. What about this building? What is this building? I don't know this building, but it looks symmetrical this way, yes? Okay. Bumpy road, line of symmetry, line of symmetry. How about this? Where? Middle here lah. But yes, must choose your words properly, vertically and horizontally. Can or not? Diagonally, can or not? Think. So if I draw it diagonally, imagine you fold. Oh, you see. Confirm same? What about the rectangle? Confirm same? Not same or what? The circle will be the same, but the rectangle will not be the same. Okay, so suppose I want to I want to reflect this portion of the rectangle along this line. So when I fold it, I'm going to end up with this shape. Can see the reflection diagonally from here to here. That is no longer the same already. So are there any objects in our classroom that are symmetrical? Okay, where's the line of symmetry? No, for the table, where's the line of symmetry? We got diagonally, already say rectangle there diagonally. So vertically, like in front of you, okay, left and right, same. If you can fold it up, you will get the same shape. Okay, whiteboard, yeah, because it's a rectangle. The what? The glass, is it? Yeah, okay, they are rectangles. All right, any more? Fan. Which fan? Ceiling fan. Okay, if it stops, yes, it is going to be symmetrical. Any more? Door. Okay, can, yes, projector also. Yes. iPad. Yes, it is symmetrical. Yep. One more. Okay, books. Hey, you're all giving me rectangles only, right? Any other shape? School field. Okay. Well, if we don't consider the numbers, if we just consider the circle, yeah, it is symmetrical. Which one? Yeah, also rectangle. Any more or not? Okay, fan say, clock say already. Have a good, really? Really? Okay, so we ignore the drawing here. If we ignore the words, this is alright. This function is not symmetrical. If you then you put bodies, put the logo in the middle, put the words, then yes, it's symmetrical. Any more? Something that you're already. I said. Okay. If you don't care about the design, that's why I said you can fold clothes, right? You fold clothes, you fold neatly, right? Yeah, okay. Your shoes also symmetrical. By right, your shoes by right should be symmetrical, okay? Blade, this blade. Yeah, okay, this circle over here is symmetrical also. Your bags, are your bags really symmetrical? Most of your bags should be symmetrical. Your mask, the mask also symmetrical, right? Actually, your face should also be symmetrical, right? By right, this way. Okay, let's go talk about your hairstyle. By right, your face should be symmetrical, but there are slight differences on the left and the right. Okay, so like in nature, we also find lines of symmetry. Can you draw the, although not very exact, can you draw the line of symmetry for the star? Yeah, the starfish at the bottom. Yes, please draw a line of symmetry. Draw. Try. I mean, for the flower, the bird, the butterfly, quite obvious. What about for the star? Can? Vertically? Okay. Any more? No more. What if you rotate your book? Not same, eh? This one not the same, eh? Why cannot? Why cannot? Cannot. Yeah, because the star, hey, there are more. Yeah, so if you turn your book 360 degrees, you'll find that there are actually 5 lines. Of course, this starfish is not perfectly symmetrical. But if you draw a perfect star, which I cannot do, which I cannot draw a perfect one, you will find that actually there are 5 lines of symmetry. Vertically down, 1, 2, 3, 4, and 5. There are 5. So far, so good. Simple enough. Okay. Some shapes have only one line of symmetry. For example, this heart shape. For example, the blue triangle. only one line of symmetry. Some shapes have got more. For example, this equilateral triangle. Did you all learn equilateral in primary school? Equilateral. So equilateral means three sides same length. Three sides having the same length. In addition, because of that, three angles are all 60 degrees. Fari, are you all right? You look like you're going to fall off the table already. All angles are 60 degrees. So in this particular triangle, there are three lines of symmetry. And then you talk about a four-sided figure. A four-sided figure, in this case a square, it has four lines of symmetry. Okay, so now I want to do a quick discussion. Do all triangles have three lines of symmetry? All triangles, do they have three lines of symmetry? Okay. You can easily draw another triangle, right? And realize that actually this particular triangle that I drew, no lines of symmetry. For another triangle, maybe I draw an isosceles triangle. Then this has one line of symmetry, right? So a triangle can have one line of symmetry, can have no lines of symmetry, can have three lines of symmetry. Yes? Okay, so far? So how many sides does a triangle have? Three sides. What is the maximum number of lines of symmetry that you can have? Three, very good. And that belongs to a special triangle. What is that special triangle called? Yes, equilateral triangle. Okay, we move on. Now we have a four-sided figure. Four-sided figure can be a square. It can be a rectangle. It can be a parallelogram. It can be a trapezium. It can be just any other random four-sided figure, right? In all these cases, is it possible to have no line of symmetry? Is it possible to have no line of symmetry? Yeah, this one has no lines of symmetry, no lines of symmetry. Then it is also possible to have just one line of symmetry. It is possible to have two lines of symmetry. But what is the maximum number of lines of symmetry for a four-sided figure? When does that happen? When do we have four lines of symmetry for a four-sided figure? Which shape would that be? Yeah, it's a square. We don't need to say perfect square. Yeah, it's a square. So basically, we realize that for a four-sided figure, maximum line of symmetry is 4. It happens when it is a square. So what is so special about a square compared to all the rest? What is so special about an equilateral triangle compared to the rest? What is so special about the equilateral triangle and the square compared to their counterparts? Anything special about them? So turns out for a square, all four sides are the same length. For equilateral triangle, all three sides are the same. All the angles in the equilateral triangle are the same. All the angles in the square are the same. When you have a case like this, your line of symmetry will be the number of lines of symmetry will be the number of sides your figure has. Therefore, if we extend this to a 5-sided figure, let's draw a 5-sided figure. 1, 2, 3, 4, and 5. If we have a regular 5-sided figure called a pentagon, where all the sides have the same length, how many lines of symmetry do you think you can get? One only, man. Just now we said 3-sided figure, all same length, we get 3. 4-sided figure, in that case a square, you get 4. What about a 5-sided figure? You should get 5 lines of symmetry. And where are they? 1, 2, 3, 4, and 5. You should get 5. Right, so this is 1. Then we've got another one here. We've got another one here. 3 already. Got one more, 4, and 5. There are 5 of them. So what if we now have a 6-sided figure, a regular 6-sided figure called a hexagon? How many lines of symmetry will this have? Can you find the 6 of them? 1, 2, 3, 4, 5, and 6. Okay, so 7-sided will have 7, 8 will have 8, so on and so forth. Provided that they are regular, meaning all the sides they have the same length and the angles are the same. So many lines of symmetry does a rectangle have? We talked about it just now. First one, we have only 2 lines of symmetry for a rectangle, your vertical and your horizontal. Diagonal will not be a line of symmetry as shown over here. All right, so work example number 1. Is it are these lines of symmetry? Yes or no? Yes, for regular. The words regular. So right now in your textbook, regular, what does it mean? All sides same length. Okay, the word regular, and all angles equal. So there are 2 parts to it. All the sides they have the same length, and all the angles are equal. You see that the angles over here, they look like they are the same because they are the same. All the angles in this heptagon are the same. So for a 3-sided figure, that would be our equilateral triangle. For a 4-sided figure, it will be a square. For a 5-sided figure, pentagon, then hexagon, so on and so forth. Okay, oh, it's actually written over here. Okay, so to determine whether it is a line of symmetry, we fold it. During your test, can you fold your paper? Can or not? Can. You can fold your paper if you want to, but you don't go and crumple your paper, huh? You fold neatly according to the dotted line, and then you hold it against the light, but you don't hold your paper all the way up to show everybody your work. You fold it, you hold it against the light to see whether you can get the two sides to match. Understand what I'm saying? Hold it against the light so you can see it. That's why I say don't hold it so high up for everybody to see. Just hold it a little bit, just for yourself to see only. So what about this heptagon? If you try and fold, you will not get the same shape on both sides. How do we confirm that? If you look on this side, 1, 2, 3, 4. 1, 2, 3. They don't match. 4 points on one side, 3 points on the other side. Cannot. So this particular one is not a line of symmetry. But does this shape actually have lines of symmetry? Have. It is a 7-sided regular figure, so there should be 7. Just that this is not one of them. So if you want to draw, find the midpoint vertically down. To check 1, 2, 3 points over here, 1, 2, 3 points on the other side. So that's one line. You can draw more of them. 2, 3, 4, 5, 6, 7. Okay, so now try it. Is the dotted line on this shape a line of symmetry? Just have to state yes or no. Yeah, think about it. Think about it first. Don't say all your answer. Okay, once you have decided, write it down in your book. A, is it a line of symmetry? Shah, is it a line of symmetry? No. Okay, why not? Which part not equal? If you want to fold it, it's not the same, right? Well, like for example, you can also count like there are 1, 2, 3 points over here. Then when you fold over, if it is symmetrical, the other side should have 3 points also, isn't it? But the other side has 1, 2, 3. Oh yes, 4 points. So it's obviously not symmetrical already. What about the decagon? Decagon. How many sides? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 sides. So the word decagon, 10 sides. Okay, so this is yes, and this over here, no. By the way, octagon. How many sides? What does the word "op" remind you of? Yeah, octopus, right? Octopus, how many legs? Octopus, 8 legs. What does the word deca remind you of? December. December. Okay, actually quite interesting that you think that it is related to DECEMB or December. Then what about over here? October, right? But October is the 10th month one. Then December is the 12th month, right? Come like off, a bit strange, right? Shouldn't October be month number 8? Shouldn't December be month number 10? Because another word that we can remind ourselves about is DECADE. This is what? Decade, 10 years. Number 10, right? Then what's wrong? What's wrong with December and October? No, something went wrong. Last time, long ago, we had 10 months in a year. Yeah, many years ago. We only had 10 months. Then October was month number 8. Makes sense. December was month number 10. Made sense. Then at some point in history, they decided, hey, we're going to add 2 more months inside. I can't remember which are the 2 more months. So they pushed October back to month number 10. They pushed December to month number 12. Okay, so that is obviously not tested. But my point is, you think of octopus, don't think of October, otherwise you'll mix up. DEC, you think of decade, don't think of December, otherwise you'll mix it up. Okay. Then what are some other words? Heptagon, 7 sides. Hexagon, 6 sides. What about a 5 side? What is 5? Pentagon. Do you know a very famous building called the Pentagon? Don't know. No, not Singapore. It's in the US. Okay, let's see.
Oh, okay lah.
Do this.
So your pen was here or
Part A,
bottom?
Part B.
Almost actually here.
Not in the testicle.
8A. Is this a dotted line? Answer no. This is yes. Find the number. If they say number, then you must write out a number. In part A, the answer is 1. Where is the line of symmetry? Vertically, like this. What about for the star? 1, 2, 3, 4, and 5. What about for this? What looks like a stop sign? This one here. 1. Oh, there are 2. What about this? 1, 2. What about the sun? 8. Okay, so these are 1, 2, 3, 4. Oh, where are the other 4? Here. 5, 6, 7, 8. In between the triangles, also considered. So we got 8 over here. Which part weird? Why is it weird? Okay, now which letters in a word have only one line of symmetry? Only one. Y, M. Yes. S. Does S have any line of symmetry? S don't have. Find the number of lines of symmetry for each of them. Okay, so the letter X. 1. So cannot. Cannot. So 2. 8 will be 2. Vertically, horizontally. Horizontally 1. What was that? Which one? For which letter? Because this X, right, is more of a rectangular shape. Can you see? It is not squarish. If it is squarish, then yes, can. But because it's a rectangle, then cannot. Understand what I'm saying? Okay, so for the letter Z, how many? What? 0. Letter Z, 0. Okay, so what do you think about lines of symmetry? Yeah, is it something that confuses you? Is this a topic that you should have the least confusion? Should be the least confusion, because it's either line of symmetry or it's not. So your objective should always be to make sure you get full marks for a line of symmetry. Okay, so let's do 8A for your workbook now. Exercise 8A. We're going to do some drawing as well. Okay, the entire exercise 8A. Yeah, do it now. Very simple one. Until page 47. Page 47. Okay, let's start with the first one. 1A. Is the dotted line a line of symmetry? State yes or no. So this answer, yes. This also yes. Part C, no. No. Find the number of lines of symmetry. I saw that many of you could draw the correct one line of symmetry, but you did not answer the question. You left it like this. They asked you to find a number, so you must write 1. This will be 0, 4, and 1. 2, where 2? Okay, any questions? They did not ask you to draw, but you should draw. More important one is to write down the final answer. So where are the 4? 1, 2, 3, 4. Draw all the lines of symmetry. This is a regular octagon, 8-sided octopus, octagon. So we got 1 right smack in the middle. 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 of them. Sorry, this is not an octagon. How many sides does it have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, sorry, this is a decagon. I didn't count properly. So there are 10 lines of symmetry. And then for this shape, this star shape, 1, 2, 3, 4, 5, 6, 7. Complete each shape. Okay, now you get to criticize my work. Okay, I'm going to try draw freehand. What do you think on my work? Acceptable or not? Not acceptable, right? What's wrong with it? Yeah, it's not the same size. What should I do? Bigger? Like this, okay? Is this okay? Really? Yeah. It is a little too big. Say, you see, we can see and we can tell when something is not symmetrical. Because when it's not symmetrical, usually it is quite ugly, right? Make it smaller. Draw until you're satisfied. Okay, better now? What about the crescent shape, that moon shape? Is this okay? How about this? Is this okay? Like a bit too slanted, huh? No, too short. Not straight. Okay. And the last one, the arrow. So complete each shape. Given that the dotted lines are lines of symmetry. Is this okay? Confirm okay? Can ah? It's not wrong. The bottom is too fat. Like this. Now it is okay. So likewise. Is it okay? No, okay. Okay, later I try again. Third period. Okay, class that.